Welcome to the Old Man's Minecraft channel. I hope you enjoy the video, so let's get to it. Okay, for this tutorial I'm using the Minecraft Windows 10 Bedrock Edition. And now for the tutorial. An aerial shot of the setup that I've got, and it is using a power source of a redstone torch, which is at the back of the redstone comparator there, and out the front is the signal that, as you can see, it's bright red when it comes out, and as it progresses to the right each block the signal strength drops by 1, and so the redstone dust will get dimmer and dimmer until the 15th block, at which point it is a strength of just 1. The next block to the right is the 16th block and the signal strength is 0, and you can tell by the redstone lanterns there, they're all lit up except for the very last one on the right, and that's because a redstone lamp only requires a signal strength of 1 to power it. So this is a good illustration of the strength number 1 that's coming out of that redstone torch being 15 at its maximum, and as you progress to the right the redstone dust gets dimmer and finally it has no power, as indicated by the last redstone lamp there. The next thing to demonstrate is if you look at the trace that's coming out of the side of the comparator there, and it's going to a lever, because there are 6 blocks of redstone between the lever and the redstone comparator. When it comes out of the lever it is signal strength of 15, and then it progresses down to where it is only a strength of 10 when it's going into the side of the comparator there. Right now that signal coming in from the side has no effect whatsoever on what's coming out of the front. But if I were to right click on that redstone lamp there at the front of the comparator, that will put it into subtract mode, and I'm going to go ahead and demonstrate that by going down, and I'm going to turn on the subtract mode by right clicking on that front there. Now it is in subtract mode, and basically what that means is the comparator will take the signal coming in the back and then subtract from it the signal coming in the side. So we've got 15 coming in the back and we've got 10 coming in the side, and so you can see, if I go back up, you can see that the comparator is only lighting up the difference between the signal from the back, which is 15, and the signal from the side is 10. So it's subtracting 10 from the 15, and so what comes out the front of the comparator is just 5. So that's 2 different modes that you can use the comparator for. The first is just comparing the signal, and the second is putting it into subtract mode by turning on that front. So turn this back off, and as you can see it's lighting up the entirety again except for that last one. So I've demonstrated those 2 features, and now I'm going to demonstrate how you can use the comparator to measure the contents of a container, and I will show you that next. Okay, now as you can see there is no signal coming out of the front. That comparator there is now being used to measure the contents of that hopper there. So now let's go back down, and I'm going to show you something about the hopper. And if we look inside the hopper now, these 5 blocks or cells up here are the hopper capacity. So basically, each one represents 20%. So if I was to take a single non-stackable item and drop it in there, that consumes that entire cell capacity. So seeing as how there's 5, each one of them, if assuming that they are full, well, full or empty, each one represents 20% of the total capacity of this hopper. So if I were to take the maximum signal strength of 15 when this was full, that would mean that each one would be a signal strength of 3 for each one that was full. And I'm going to first show you that if I have just one in there, it's going to light up just 3 of the lanterns there, which you can see is true. Okay, if I go in and I were to add additional ones, let's go with just adding another one. Now if you look, it's actually lighting up 6. Okay, there's an aerial view which is a little clearer, and as you can see, because 2 of the 5 are full, then it's lighting up a total of 6 of those lanterns, which is accurate. Now let's go back down. There we go. And now if I were to right click on it and go in and I were to fill it full, I don't have another hatchet, so I'm going to take this block of 64, and let me point something out here. The 4 axes are non-stackable items, so if you place one of those in there, that cell is full. If you look at that last one, the chest, there's 64 of them, and that is a stackable item, which means I could conceivably take half of those out, and basically what that's going to do is demonstrate that when it comes to the capacity, the Redstone Comparator can detect that a cell within this container is partially full. So basically what I would expect here is it's going to give me a signal strength of 3 for each of these first 4, so that's going to add up to 12. And because it's 3 but it can't do 1.5, it's going to round it up to 2, which means 3, 6, 9, 12 plus 2 would be 14. So if we go out and take a look, here we have another aerial view. What I've noticed in testing is the inconsistency of the strength that it'll give you for a partially full cell sometimes. Sometimes it'll give you 1 of 3, and sometimes it'll give you 2 of 3 when the cell is half full. Well, the point here is that it does detect a partial signal strength. The cell is partially full. It does detect that. So I guess the takeaway from this example would be that the measuring feature of the Redstone Comparator is not exact. I mean, you can't, just looking here without looking inside the hopper, you can't tell a precise number of what's in the hopper. All you can tell is a rough indication of the fullness of that container. So without looking inside the hopper and counting the items and recognizing that some cells have a non-stackable item and other cells have stackable items, there's no way for you to tell from this precisely how much of the container is full and what exactly is in it. This is just going to give you a ballpark, basically, of what's in it, knowing that if it was slap full, you would have 15 of these lanterns lit, and if it was slap empty, you would have none of these lanterns lit. And anything in between, it's going to give you a rough idea of the container and how full it is relative to empty versus full. Man, I like the aerial view here. Okay, what I'm going to demonstrate here is another feature of the comparator, and right now I've got a redstone torch feeding into the back of the comparator, and the strength of it, because of there's 3 blocks of redstone, so 15, 14, 30, so the strength going into the back would be 13, and it's lit up all of those redstone lamps there. Now the thing that's coming in to the right from the side there with the lever, that is, when I turn it on, that will apply power to the comparator. And the way this works is, if the signal coming in from the side is more powerful or stronger than the signal that's coming into the back, it disables the comparator, and the comparator will not output anything from the front as long as that stronger redstone signal is coming in from the side. And so you can see that right now what's coming in from the back is lighting up all those torches. But if I go up here and turn on this lever, because that is a stronger source, it's essentially 15 strength going into the side, which is stronger than what's coming into the back. It closes the comparator down so that no power comes out the front, and as you can see, that is in fact the case. So I don't know what you would necessarily use this feature for. I'll leave that up to you to think something up, but that is a feature of the comparator that you can make use of if you can think of an application to utilize it. So I'm going to go ahead and turn this back off, and you'll see that the power going into the rear lights that back up again. So there is one caveat to mention, and that is, in the earlier example where I said the trace coming in from the side would have no effect, that is true because the source coming in from the back was 15. So what I just showed you could never shut it down, because it would have to be a stronger signal, and there is no stronger signal than 15. But if the back was less than 15, then you could introduce a stronger signal and shut the comparator down. That's the end of this. Hope you enjoyed it. Good luck. Once again, thank you for watching. If you liked the video, I'd appreciate it if you'd mash that like button. Also, don't forget to subscribe and click the notification bell so that you don't miss any future videos. Thank you.